Hello viewers, and welcome back to Fafana Maths class. In our previous video, we did look at differentiation of a product, okay, where if you have functions which you cannot easily multiply or divide in order to put them in separate terms for it to be easy for you to differentiate, we use the product rule to, tackle that particular expression or that particular question. And in another scenario too, you can have an expression which you can also not multiply or divide them easily for you to be able to differentiate. So another way of tackling those problems is to use the quotient rule to solve it. Now with the quotient rule, if you have a function which is y to the power uv, okay, u over v, where u and v are functions of x, okay, u and v, they are all functions in x. All right, now with the quotient rule, if you want to find the derivative or the differential coefficient of such expression or this particular function, what you have to do is divide the x. The formula to use will be here, you will keep one of them, which is v, then you differentiate u the x, okay, you differentiate u, then minus, you keep u, then you differentiate v, all right, all over v square. Okay, so this is the formula that you will be using when you have a function in this form, which is u over v, okay, where u and v are all in functions of x. All right, then if you want to solve that particular question, this is the formula that you will be using, which is dy dx is equal to, you keep first the v, then you differentiate u. All right, so you use that u to multiply them, minus, you keep u, then you differentiate v, then you use that v to multiply the u, all over v square, then you will be obtaining your dy dx. Okay, now we have these two questions on the board which we are going to use to illustrate this particular formula that we just looked at. All right, now we have these two questions on the board which is asking us to find the differential coefficient or the derivative of the questions. Okay, now the first thing that you have to do using the formula is the first question, okay, we let u to be equal to 2x plus 3 and then v to be equal to x minus 5. All right, so now when we differentiate u, you will be obtaining du dx to be equal to 2, and then here when you differentiate v, you will be obtaining dv dx to be equal to 1. Okay, so now when you substitute this into the formula, this is what you will be obtaining, dy dx to be equal to, now we have v here, so v is equal to x minus 5 times du dx, so du dx is 2, all right, minus, what is our u? Now we keep u, right? So u is equal to 2x plus 3 times dv dx, which is 1 all over v squared. What is our v? V is equal to x minus 5, right? X minus 5 squared. Okay, so dy dx will be equal to, now we expand the bracket, we have here to be 2x minus 10 minus 2x minus 3, all right, all over x minus 5 squared. Okay, so by simplifying, you have dy dx to be equal to 2x here, will cancel this 2x and it will be left with minus 13. Okay, so we have minus 10 here, minus 3, we have minus 13 all over x minus 5 squared, and this will be the solution for, or this will be the derivative for the first question. Now quickly we will look at the second question. I'll urge you to pause the video and then solve the second question. Okay, after that, then you play it, then you compare the answer that you have obtained with the one that I am about to obtain. Okay, now we have the second question on the board, which is y is equal to 1 plus x squared all over x minus 1. Okay, so just like we did for the first one, all you need to do is to let u to be equal to 1 plus x squared, then v to also be equal to x minus 1. All right, now what I want to tell you is I would appreciate it if you will pause the video, then you solve it on your own using the approach that we used with the first question. Then after solving it, you continue with the video to compare the answer that you have obtained with the one that I'm about to obtain. Okay, now you differentiate the variables, which is u and v. Okay, so when I differentiate u, I will get du dx to be equal to 2x, and then when I differentiate v, I will get dv dx to be equal to just 1. Okay, so from here I will just substitute the values of the v and u into the formula. Okay, so dy dx will be equal to v is equal to x minus 1 times du ds we obtained what, 2x. All right, so minus u, our u is equal to 1 plus x squared, so times dv dx, which is 1, all over v squared. So v squared is equal to x minus 1 squared. Okay, so dy dx, by expanding the bracket, we have here to be 2 times x, we have 2x squared minus 2x minus 1 minus x squared. Okay, so from there all over x minus 1. So now from there our dy dx will be equal to 2x squared minus x squared, here we have x squared, then minus 2x minus 1. All right, so minus 2x minus 1 will be all over x minus 1 squared. Okay, so from here this will be the final answer for the second question, which is what, this. All right, so what did we do? First of all, you let u to be equal to the first function, which is u, then the second function will be what, v. Then you differentiate the two functions. Okay, then you substitute the values into the formula. All right, so when you substitute the values into the formula, this is what you'll be obtaining. So after obtaining it, you solve it one after the other systematically. This is where you will be arriving. Okay, and this will bring us to the end of the quotient rule of differentiation. In my next video, we'll be looking at how to differentiate using the implicit function, okay, and then the chain rule. Okay, so we will look at chain rule and then the implicit. Okay, so stay tuned and watch out for my next video, and don't forget to share for the benefit of others. Have a nice day.